Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Let's look at chain rule. This is also called what? The core what? The core function. Also called function of what? Function of a what? Of a function. It's also called function of a function. Either. For example, let us look at some example. Let's say example 1. If we are given y equals to 2x plus 4, let's say 2x squared plus 4, all this power 6, and we have to find the y, the what? The x. Are you following? We have 2x plus 4 raised power 6. And if I have 2x plus 4 raised power 2, it is easy to expand first, Abi. But for this, I can't expand this. It will take me more time. So the only way to solve it by using what? The function of what? Of a function. Or we use our chain rule. Now what? Solution to this is very simple. The first thing we have to do is to represent u with this co-function here. I'll say let u equals to what? 2x squared plus what? 4. Let u equals to this. If your u equals to this, that means what? Y becomes what? U raised power what? 6. Is that clear? So I can say this is equation 1, Abi. This is what? Equation 2. Then I would then differentiate these two equations using the power rule. You know, the power rule, we say that multiply the power by what? Quotient of the x, Abi, and subtract 1 from the power. So I will differentiate u with respect to x, and differentiate y with respect to what? To u. So differentiating u, it means the u, the what? The x. That will be what? Let's go. What is 2 times 2 here? That will give us 4x, Abi. Plus what? Plus 0. But that should be what? 4x. Is it not so? Then let's differentiate what? Y with respect to what? To u. Meaning the y, the what? The u. That will give us what? 6u raised power what? 5. Is it making sense? The first thing we need to do here is to say let u equals to this function here. If your u, you can even use v or anything. But I always like using what? U. If u equals to this, it means my y equals to u raised power 6, which is this. Then differentiate this, we have this. Therefore, the y, the x will then give us what? The product of what? The u, the x, and what? The y, the u. Meaning when you multiply this with this, and we have what? The y, the x. So that means the what? The u, the what? The x times what? The y, the what? The u. Do you know what is true? Do you know what is true? If you divide, if I should divide this can cancel this, Rabi. Remaining what? The y, the x. That means this expression is equals to this. So I can multiply them now, right? So let's go. That will give us what? The y, the what? The x equals to what? What's the u, the x? 4x. Times, what's the y, the u? 6 what? U raised power what? 5, Abi? And that will give us what? What is 4x times 6? What do you have? 24 what? X, right? U raised power what? 5. Therefore, our dy, the what? The x will be what? 24x. What do you say is our u again? U is what? 2x squared plus 4. I have to import this and put it here. That will give us what? 2x, Abi? Raised power 2 plus what? 4. All raised power what? 5. Final what is there? Final answer. But there's another short form for chain rule. Huh? Can I show the short form? Okay. There's a short form for chain rule. Now listen, the shortcut. There's a shortcut for this. The shortcut for this is simply this. Please watch. Formula for co-function, Abi, for the chain rule. Please watch. The shortcut simply says that the y, the what, the x is equal to normal differentiation times differentiation of the co-function. What's that end representing? Normal what? Differentiation. Multiply with what? Differentiating the what? The co-function. Normal means I will use my power rule to differentiate. Normally. Meaning for this, I multiply 6 by what here? By 1, abi? Here becomes 6 brackets. 2s squared plus what? 4. Always power what? 5. Then you now differentiate the cool function. That will give us what? 4x. Let's apply it and see. Watch. Divide the x will give us. What's our normal differentiation? 6, abi? In bracket, what do you have here? 2s squared, abi? Plus what? 4. Always power what? 5. Right? Multiply with. Differentiate the co-function. What's our co-function? Is it not this one here? What? Let's go. What do you have? 4s plus 0, abi? Which is the same as what? 4s. This 4s times 6 is what? 24 what? X. In bracket, 2s squared plus what? 4. Right? Always power what? 5. Example what now? Example 2, abi? If we are given this, y equals to 1 plus s cubed. 1 plus s cubed always power 2. And we have to find the y, the s. This is very simple, right? How do we solve this? You can't tell me. We say let what? Let u equals to what? You can't tell me. 1 plus what? S cubed, baby. Then my y becomes what? U squared, is it not? So I will differentiate the two equations, right? So we have what here? The what? The u, the what? The x. We give us what? 3s squared. Hope you are aware. When differentiate 1 is 0. Differentiate is what do you have? 3s squared. So what? Let's go. Let's differentiate the y, the what? The u. What do you have? 2u. So our dy dx becomes what? The u, the what? The x times what? The y, the what? The u. And that will give us what's that? The u, the x? 3s squared multiplied by what? Times what? 2u. So 2 times 3s squared is what? 6s squared. Is it not? 6s squared what? U. Are you following somebody? And that will give us what finally? What's that? The y, the x? 6s squared in bracket. What's that? U. 1 plus what? Where is it? 1 plus what? S cubed. Are you getting the gist? For this kind of question, I can easily expand this because I don't have any power here. I can say 6s squared times 1 is what? 6s squared. Is it not so? Then 6s squared times s cubed is what? 6s raised power what? 5. Do you get the gist? Can say expand that. Huh?